Welcome to volume finding techniques in summary. So first off, we saw disks. So this requires our cross sections to be completely solid. If we have our completely solid cross sections, we have our two versions. So for rotation about the x-axis, we had our volume was equal to the definite interval from A to B of pi times r of x squared times dx. For rotation about the y-axis, we had volume was equal to the definite interval from A to B of pi times r of y squared times dy. So about x-axis, we had the vertical cross sections, they had thickness dx. For rotation about the y-axis, we had the horizontal cross sections with thickness dy. Let me just update my screen quickly. The rotation about y-axis, we had volume was the definite interval from A to B of pi times r of y squared dy. Moving into washers, these no longer required the solid cross sections. So no longer requires solid cross sections. For our rotation about the x-axis, we had that the volume was equal to the definite interval from A to B of pi times the outer radius, capital R of x, squared, minus the inner radius, lowercase r of x, squared, whole thing times dx. For a rotation about the y-axis, we had our volume was equal to a definite interval from A to B of pi times capital R of y squared minus lowercase r of y squared, whole thing times dy. So again, when we're doing rotation about the x-axis, we use vertical cross sections for our washers. They have thickness dx, so everything was in terms of x. When we do rotation about the y-axis, we're looking at horizontal cross sections. They have thickness dy, so we're looking at everything in terms of y. For our shells, in this case, again, we do not need a solid cross section. So shells do not require solid cross sections. The way shells work, for rotation about the x-axis, we're looking at cylinders that are on their side. The thickness is actually dy this time around. So for rotation about the x-axis, our volume was equal to the definite integral from a to b of 2 pi times r of y times h of y dy. For rotation about the y-axis, these are the cylinders vertically. Since we have our circles are horizontal, the cylinder will be vertical. And so these are our thickness is dx. We have v is the definite integral from a to b of 2 pi times r of x times h of x dx. So note when we're choosing between discs and washers versus shells, it's just a matter of, is it easier to work with the function or its inverse? So note, when choosing to work with discs or washers, versus shells, it's really a matter of asking, is it easier to work with the function or its inverse? And then depending on whether you are rotating around the y-axis or the x-axis, sometimes it's the function that gets squared for washers, sometimes it's the inverse that gets squared. So that also has an input. But sort of paying attention to what your two integrals look like, then you can see which one might be easier to work with. So that is volume using discs, washers, or shells.